Hello friends. In last lectures, we have gone through beta distribution of first kind, its density function, r moment, mean and variance, harmonic mean, and symmetricity property of it. In today's lecture, we will go through mode of beta distribution of first kind. So let's move towards mode of beta distribution. We know the density function of beta distribution of first kind. So let x be a random variable having beta distribution of first kind with parameter m and n. Therefore, the density function of f of x is 1 upon beta mn x raised to m minus 1, 1 minus x raised to n minus 1, where x is lies between 0 to 1 and mn should be positive and 0 otherwise. Now we want to find the mode of the distribution. So for finding the mode, we have to follow the some steps for the mode, that is procedure. So firstly, we want to solve the equation d dx log of fx equal to 0. That means taking the log on this function and differentiate it with respect to x and it equal to 0, and by solving this equation we get this x, which is denoted as x naught, and second step is verify that d square by dx square, that means second derivative with respect to log of fx at point x is equal to x naught is less than 0. So this x naught point is your mode. Okay. So for this, we firstly take the log of this function. So that means this I have to taking log on this function, we get log of f of x is equal to log of 1 upon beta mn x raised to m minus 1 minus x raised to n minus. Okay. Now after differentiate this equation with respect to x, then we get d dx log of x log of f of x, which is equal to d dx or dy dx log of 1 upon beta mn x raised to m minus 1 minus x raised to n minus 1. Okay. So that means which is equal to d by dx, this log of 1 upon beta mn plus m minus 1 log of x plus n minus 1 log of 1 plus log of 1 minus x. So log of 1 upon beta mn is a constant terms because m and n are positive, so beta mn is constant term. So log of constant, derivative of this again this constant term is 0. Okay, this log of constant term is there, so this term is again constant, so derivative with respect to x, this constant term is 0 plus m minus 1 derivative of log of x. So this I have to just write d by dx log of x plus n minus 1 d by dx log of 1 minus x. So this derivative with respect to x of this log function is nothing but the 1 upon x. So this m minus 1 upon x plus n minus 1 upon 1 minus x, and this minus x has derivative minus 1. So that means which is equal to m minus 1 upon x minus n minus 1 upon 1 minus x. Okay. So equating to this term, that is d by dx log of f of x is 0. This equating to this term in 0. So we get this d by dx log of fx is nothing but this term d by dx log of fx. This term is this. So that's nothing but this is m minus 1 upon x minus n minus 1 upon 1 minus x, and which is equal to 0. So which is equal to m minus 1 upon x, and this negative term is going to the right side. That means which is equal to positive terms, that is n minus 1 upon 1 minus x. Now I have to just, this m minus 1 term is here numerator, which is right side in the denominator side, and this denominator term is here numerator. So that is 1 minus x upon x equal to n minus 1 upon n minus 1. Okay, that means this is 1 upon x minus 1 equal to n minus 1 upon m minus 1. That means one upon x is equal to 1 plus n minus 1 upon m minus 1. That is m minus 1 plus n minus 1 divided by m minus 1. So that means this 1 upon x is nothing but m plus n minus 2 divided by m minus 1. Okay, so I have to reciprocal of this, so this x is equal to m minus 1 upon m plus n minus 2, and this term is nothing but, here I have to just mention x naught. Okay, this is just the x naught term. Okay, so now consider the second derivative with respect to x of log of f of x. That means d dx by d dx of log of f of x, and we know that the d dx by log of x, log of f of x is this term. This is your d dx by log of x term. Okay, this is your d dx by log of x term. So I'll just put here this term m minus 1 upon x minus n minus 1 upon 1 minus x. So which is equal to m minus 1 d dx of 1 upon x minus n minus 1 d dx of 1 minus x raised to minus. Okay, so that means this m minus 1 into minus 1 into x raised to minus, since, sorry, the minus 2, since derivative of x raised to n minus 1 x raised to n minus 2. So I have used this result here. Same here, minus n minus 1 minus 1 1 minus x raised to minus 2, and again the derivative of minus x is minus 1. So finally we get minus m minus 1 x raised to minus 2 minus plus again here minus n minus 1 1 minus x raised to minus 2. Here this is minus 1, this is minus 1, the plus, so this minus sign is as it is here. Okay. So here I have just put the x as m minus 1 upon m plus 1. This put x is equal to m minus 1 upon m plus n minus 2. So we get this d square by dx square log of f of x at that x is m minus 1 upon m plus n minus 2. So we get minus m minus 1 m minus 1 upon m plus n minus 2 raised to minus 2 minus n minus 1 1 minus m minus 1 upon m plus n minus 2 raised to minus 2. Okay, so after solving this, what we get, already we have this minus m minus 1, this is the denominator of denominator, that is plus n minus 2 square divided by m minus 1 bracket square. Okay, so here same here minus n minus 1 and your m plus n minus 2 bracket square. This is the LCM from here, and the denominator term is your this m plus n minus 2 minus m plus 1 bracket. Okay, so here m get cancelled, n minus 1 only, this term is remaining there. This I have just cancelled this term. Here this m minus 1 cancel with this, so only the remaining term minus m plus n minus 2 bracket square upon m minus 1 minus n minus 1 m plus n minus 2 bracket square divided by n minus 1 bracket square. Again cancel with this n minus 1 n minus 1. Then finally we get the m plus n minus 2 bracket square outside here, that is minus sign is here, and 1 upon m minus 1 plus 1 upon n minus 1 is here. So after solving this, what we get is minus m plus n minus 2 bracket square n minus 1 plus m minus 1 divided by m minus 1 n minus 1. That means here again this term is m plus n minus 2, and with this multiply here we get m plus n minus 2 bracket square divided by m minus 1 n minus 1, and this term is less than 0 since m and n are positive terms, and that subtract from that term m plus n, subtracting 2 from this, add a sum of the m and n and square it. So again this term is positive, m is positive, so m minus 1 into n minus 1 is that both terms are also positive, so whole term is positive and multiply by minus, this term is negative. So this satisfied your second condition. So that means your x is equal to x naught, which is equal to m minus 1 upon m plus n minus 2 is mode of x, that means the mode of beta distribution of first kind. This is your mode of beta distribution of first kind. Okay, so only remember thing that here m plus n is greater than 2, so that case this mode is exist. Okay, so thank you so much.